Hello everybody. So we are talking about tri-trees. This is the second installment of a three-part series on tri-trees. The first part we dealt with what is a tri-tree and we built a tri. We made the initial node and then we inserted into the tri. And so if you need to see what that is, you can go back and look at the first installment. At the start of every single one of these episodes, I have to say that I'm still a student going for my bachelor's in computer science, so I'm not a professional yet. I'm actually taking a little break from college at the moment, but that just gives me more time to program and to do my side projects, which is what everybody wants, really, isn't it? You want the time to program and to do your side projects. And to make money. I'm not at the making money part yet, but that'll come in time. So let's talk about a tri. So first we've talked about what is a tri and how to create a tri. Now we're going to talk about how to search through the tri and how to delete items from the tri, how to delete words from it. Alright, so here this is what we created last time at the very beginning of the last episode. We made a tri, we inserted these 5 words, ABBA is in there twice. So now what we're going to do is we're going to talk about how to delete from the tri. So are we going to delete one of these words? Well, the first thing we're going to do is we're going to search for the word. We have to make sure the word exists. If the word does exist, and then we're going to start at the ending node. So for ABBA, once we search for the word, we find it right here. We start at this ending node, the A. ABS, ABS, we'll start at the S, and so on. And then the very first thing we do is we decrement the occurrence of the node by 1. So as we know, once a word is in the tri, the very last node gets incremented by 1. So ABBA is in here twice, so the occurrences is 2. ABS, ABS, the occurrence is 1. So if it's the ending node that makes a word, the occurrence will never be 0. It will always be 1 or higher. So the very first thing we do is we decrement the occurrence of the node by 1, and then we delete the node only if it has no children. So like A has no, or this A right here has no children, this S has no children, this H has no children. So we delete the node if it has no children and if its occurrence is 0. And then when we're done with that, we move to the parent node and we repeat. So let's go through this right now and see how this works. So we're going to delete ABBA. And I'm not going to play the ABBA music. I should have had that already set up, but unfortunately we're going to be without the ABBA music at the moment. So to delete ABBA, first thing we do is we're going to search for the word. We see it right here. Then if the word exists, we start at the ending node. The ending node is this A. The first thing we do is we decrement it by 1. So if you notice A was 2, now it's 1. We've decremented it by 1. We delete the node if it has no children. Well, A has no children. Its occurrence is 0. Well, its occurrence is not 0. Its occurrence is 1. So we've gone as far as we can go. We're done with ABBA. And this makes sense if you look at it, because ABBA was in there twice, but we've only got rid of one of them. So the occurrence of A went from 2 to 1, and we're done. We left one of them in here, and we've taken out one of them just by moving the occurrence from 2 to 1. So now let's move on. Let's remove ABS, ABS. Search for the word. There it is. If the word exists, we start at the ending node, decrement it by 1. Delete the node if it has no children. This node has no children. Its occurrence is 0. Its occurrence is 0, so it's gone. Now we move to the parent node and we repeat. We will remove this node if it has no children, but it does have a child. It has this child right here, B. So we can't go any farther. We're done. We can swipe ABS off the list, which once again makes sense if you look at it, because this B was part of ABS, but it's also part of ABBA, so we can't delete this node because it's part of another word. Now let's remove CAT, C-A-T. We've searched for the word, we found it. We start at the ending node, decrement it by 1. Delete the node if it has no children. but this does have a child, has this child right here that represents C. So we've gone as far as we can go. We scratch it off the list. We have removed cat simply by decrementing from 1 to 0 at this node right here. Catch. Now we're going to remove catch. Search for it, found it, start at the ending node, decrement it by 1, delete the node if it has no children. It has no children. Its occurrence is 0. Well, its occurrence is 0, so it's gone. We've removed that node. Now we'll move to the parent node and we'll repeat. We'll have to make sure it has no children. Its occurrence is 0. Even though it's not labeled, all these that aren't labeled, the occurrence is all 0. So since its occurrence is 0, we will remove it. We'll move to the parent node, repeat. Has no children, occurrence is 0, so we'll remove it, move to the parent node, and repeat. Has no children, its occurrence is 0, we'll remove it, move to the parent node, and repeat. It has no children, its occurrence is 0, so we'll move to the parent, so we'll remove it, then we'll move to the parent node and repeat. But if you notice, the parent node now is the root, and you never delete the root. You leave the root where it is, unless you're removing the entire trie, which we're not doing. So once we reach the root, that is where we stop. We never remove the root. The root is our stopping point. So since we've reached the root, we're done. We can scratch catch off the list. We only have one more word, ABBA. So we'll search for the word. There it is. If the word exists, we start at the ending node, decrement it by 1, delete the node if it has no children. If its occurrence is 0, it has no children, its occurrence is 0, so it's gone. We'll move to the parent node, has no children, its occurrence is 0, so it's gone. Move to the parent node, has no children, its occurrence is 0, so it's gone. Move to the parent node, it has no children, its occurrence is 0, so it's gone. Move to the parent node. The parent node is the root, which means we're done. That's our stopping point. So that is kind of a higher level overview of how we're going to remove things from the trie. But now, in this process of removing things, this very first part, search for the word. That's going to be the first thing we're going to do, is we're going to show how to search for the word, and if the word exists, then start at the ending node. So we're going to make a function called search, and if it finds the word, it will return the ending node of the word. So, hey, there's a big thing that says search. So let's bring our code from last time over here. Move this guy over here. Alright, so here is the code from last time. Let's make this maximized. So last time we have our alphabet size of 26 because we're using the English alphabet of 26 characters. We're using lowercase. We created our node right here. We made the function to insert into our node. Now in order to make the delete work, we're going to have to make the search function first. So let's go ahead and get to it. We're going to return a node if it exists. So node, call you search. And node pointer try tree is what we'll call that, and we need to know the word, which would be a char pointer call you word. And then after we go and do this, we'll talk about it, so this way everything makes sense. So while the word or the pointer to the very first or whatever character in the word does not equal this guy right here, does not equal whichever character is past the final character. So while we're not done with the word, if tire tree, we're not doing tire trees at the moment, we're doing trie trees. We'll do a tire tree some other time. whichever character in the word we're currently looking at, minus case, whether it's uppercase or lowercase. So wherever we are in the trie, or at least in the children, if that does not equal null pointer. So what this is saying is, while we haven't reached the end of the word, if word minus case, so if wherever we are in the children, wherever that character, as long as it's not null pointer, as long as there is a node there, which there should be if we're looking for the word, then trie tree, if then we're going to move trie tree equals, actually I can just do this, can't I? So then we're going to move into that node, then move to the next character in the word. Else, so if in the trie tree where the character is supposed to be, if it's not, or if it is null pointer, which it shouldn't be because we're looking for a word, so if it is null pointer, which means the word is not there, then we're just going to return null pointer. So this way, whatever's calling this function will know, hey, what I looked for, it wasn't there. So then that's the while loop. The while loop will run until the end of the word. And then if trie tree that points to occurrences is not equal to 0. Now remember, the final node in every single word, it has to be something larger than 0. So if it does not equal 0, then we will return whatever node that we're currently looking at, which will be the final node. Because over here we keep moving down each character, we keep moving down to the final node. I just realized maybe instead of not equal 0, I should make that greater than 0, but it should never be less than 0. That wouldn't make sense. Else return null pointer, because if it is 0, then that means something's wrong. The final node should never be 0. It should always be something greater than 0. Now, if you notice with this final part right here, that we can do this in a little bit more of an elegant way than the way it is. We're going to play around with something that I thoroughly enjoy every time I get to use it. I don't know how to describe how much I enjoy it. It's like eating. It's like when you go out to a restaurant and you get to eat ice cream. I don't know. It's just like a treat. It's like, yes, I get ice cream this time. Now we get to use a ternary expression. Yes, we do. So another way of writing what we just wrote is this ternary. So we're going to return. Here is our expression. If it's true, we will return trie tree. If it's false, then we'll return null pointer. So return, here's the expression, here's our ternary operator. This is what happens if it's true, this is what happens if it's false. I love to use ternary expressions. It is fantastic. Alright, so this should be our search, that while we're in the word, while we haven't reached the end of the word, we'll make sure that where we're supposed to be looking is not null pointer, and then we'll move into that node, move to the next character, and keep on going until we've reached the end of the word. Come down here, as long as the occurrence is not 0, which means it's 1 or greater, which it should be, then we will return whichever node we're in. That looks correct. Let's go ahead and move this guy out of the way. Come back to search. All right. So here is what we did last time. This is where we ended last time, actually. What we did is we inserted ABS because it's only 3 characters long and I could fit it in the screen. And this is like a representation. Here is the root and it's a node. The parent is pointed to null. Its occurrence is 0. Children is pointed to an array of size, whatever our alphabet size is. This alphabet size is 26. A would be represented here. So this node, its parent points to what came before it, occurrence 0. Then children, there's the array. Here's B, here's S. So this is where we ended last time. Now what we're going to do is we're going to remove ABS, remove what we've just created in the last episode. Go ahead and put the code back up here. It covers up this part on the top right, but we don't need that. So here's the code that we just created for search. And let's do this section by section. So the first thing we're going to do is we're going to pass it a trie tree, or we're going to pass it this guy right here. We're going to start at the root. The word, we need to know what word. The word is ABS. So let's start here. While, since it's a char pointer, we start the first character of the word. While it is not equal to the space right after the final character, which it's not, we'll move into the loop. If A minus A, so here's the children of this node, A minus A is 0. While it's not null pointer, it's not. Then we'll go into the if statement, which is we will move the trie tree, we'll move that to this node. Increment word to the next character. And done with that if statement. Done there. We'll move on and we'll re-evaluate our expression up here. While B does not equal the space right after the final, it does not. Then we will move into whatever B minus A is. B minus A is 1. While that's not null pointer, or if it's not null pointer, which it's not, it has a node there. Then we will move inside the if statement. We will move our trie tree to this node. Increment word to the next character. Done with that, re-evaluate. We are not done with the word. We will look, S minus A is 18. It is not null. There is something there because ABS, this represents S. Move our trie tree to over there, which maybe calling a trie tree wasn't the best thing to call it, but we all see what's going on. And increment word to the next character, which there is no final character, so now we're at the space right after the final character. Done there. Done there. Move back up, reevaluate. Now word is 1 past the final character, so we're done with the while loop. Move down to our fantastic ternary expression over here. It evaluates to true, so we will return the trie tree. The trie tree is this node down here, so we will return the final node in this word, which is this node right here. So that is a little visual representation of how the search works and how the search, if the word exists, will return the final node in that word. And that was that. So now let's move on to delete. How are we going to delete? Well, let's bring our code back over here. Maximize that guy. Alright, so now we've got our search, which is going to be incredibly helpful. Now let's do delete. We'll make it a void because we're not going to need to return anything. Delete node. And we will give you node pointer, call you trie tree. And we will need to know our word, that's char pointer, call you word. And the very first thing we're going to do is we're going to make a node pointer that will navigate this trie for us, or we'll use to navigate this trie. We'll call it current node so we know where we are, and you will be TRIE. Nope. Yeah, that's right. Trie tree and word. Alright, so our current node will be, we're going to do the search, and if the word exists, then the current node will be the final node in that word. Alright, and what's that red line there? That's right. So, first thing we're going to do is if current node not equal null pointer. So we have to make sure that the word exists if the current node does not equal null pointer, which means that the word does exist. Then first thing we're going to do is decrement the occurrence by 1. Yeah. And now let's go ahead and make some variables that we're going to need. We need to know what the parent is. We're going to make a null pointer for now. We'll give it a we'll point it to where it needs to be a little later on. For now, we'll just make it a null pointer, and we'll make a boolean, call it isLeaf, so this way we'll know if the node is a leaf or not. And you will be defined as true at the very start. So now we have decremented the occurrence by 1. And we have set ourselves up so we can look and we can make the parent of the node, and we can tell if it's a leaf or not. So the first thing we're going to do is we're going to see if the node is a leaf or if the node has any children. So let's do a for loop. And if you guessed it, we're going to loop through all the children and see if anything exists. And I equals 0, I is less than alphabet size, plus I. And then current, whoa, look at all those words, all those letters. If current node that points to children, I not equal to null pointer, then isLeaf is equal to false. Because it's not a leaf, it has a child, and we can go ahead and break because isLeaf is false. So we're going to do a loop through all of the children, and if any of the children are not null pointer, then we know that it has a child. The current node is not a leaf. So we'll go ahead and make isLeaf false. And we'll break out because there's no need to go any farther. We know it's not a leaf. So we got that part done. While, let's see, current node that points to a parent does not equal null pointer. Do you remember when we first started and every time we reached the root was our stopping point because we never delete the root? Well, the root will be the only node that has the parent that equals null pointer. So that's what this part does. This part right here, it lets us know if the parent is null pointer, that means we've reached the root and we stop. So while the parent is not null pointer and isLeaf, we need to make sure isLeaf is true, because if it's not a leaf, we can't delete it. It means it has children. And current node that points to occurrences equal 0. And we need to make sure that our current node, its occurrences is equal to 0, because if it's equal to anything greater than 0, it means we cannot delete it. So once we have all of that, and we know all those are true, let's go ahead and start this process. Parent equals, now we'll make parent equal current node parent because we need to know what the parent is. Let's make another loop. I is less than alphabet size, plus plus. So now we're making another loop, and what we're going to do is we're going to look at all of the children of the parent. And if whatever child we're at is the current node, and we know that the current node, we know that it's a leaf, we know that its occurrence is 0, and we know that its parent is not null, so we can go ahead and start the process of removing it. Parent points to children, so we take, what are you doing outside there? So we take this this node, or we take where we are in the array of children, and we make it null pointer. So we're no longer pointing to the node. We can go ahead and delete the current node. Right, then we move the current node to the parent. And then we repeat the process. So we're going to loop, so we define what the parent is, and then we're going to loop through all the children of the parent until we find the current node. Once we find it, we will make that element in the array null, delete the current node, move the current node to the parent, and then we'll repeat the process. Let's go ahead and make an else if. Parent that points to children. And we're doing this at the same time while we're looping through all of the children of the parent. We will also make sure that the parent doesn't have any other children other than the current node. If it does, well then that means isLeaf is equal to false, because the parent is not a leaf. And we can go ahead and break out of the for loop there, because that's all we need to know, that isLeaf is false, which will stop us in the while loop. We will not continue deleting. That looks correct. Let's go ahead and see how all this works. Move this off the screen. So delete. Alright, so here we are in ABS. This is where we ended last time, and now we're going to go ahead and we're going to remove ABS. So here's our root, here's everything. Here is our code up in this top corner. I had to make it look a little bit smaller so everything fit. And it's up in the top corner, but that's okay because we don't need what's in the top right at the current moment. We will later, but we'll deal with that when we get there. So let's step through this code like we've been doing. So first, trie tree, well, we're going to pass it the root to our trie. Our word is ABS. Current node is going to equal, we're going to search for, we're going to pass along the trie tree, so we're going to pass this over, search for the word. It's going to return the final node in the word, which is down here. This is the final node. If the node does not equal null pointer, which means the word exists, we're going to decrement its occurrence by 1. So now, let's go back one. See how occurrence is 1? We're going to decrement it, so now it's 0. We'll go ahead and define parent and isLeaf. We'll make parent null pointer. isLeaf will make it to true. Now we'll start a for loop. We're going to search through all the children and make sure that this node has no children. So the current node, I is equal to 0, so we're looking in the 0 element. If it does not equal null pointer, well then we can go ahead and increment to the next one. Take a look. If it does not equal null pointer, go ahead and move to the next one. Take a look. If it does not equal null pointer, go ahead, move to the next one. And we'll just keep moving along like this. PowerPoint stopped working. Alright, well, let's wait because I don't feel like restarting all of this. Hey, hey. Document recovery. Let's go ahead and close you. I think maybe I made too big of a PowerPoint, but let's get back to right where we were because I don't feel like restarting. I don't have any editing. I have to start from beginning to end. I don't want to do that. Let's move. Where are we at? No, there is still searching. Delete. That's where we are. We're in delete. So let's start from here. From current slide. Let's change, swap this. Alright. So there's our try. Our word is ABS. Our current node is the final node in the word. As long as the current node is null pointer, decremented by 1, we'll go ahead and define parent and is leaf real fast. Then we'll search through all the children. One by one. Here we go. We'll get there. 17, 18, 19, 20th element. Almost there. So we're searching through the children. We're making sure that they're all null. And if they're not null, if you notice, then we're going to go ahead and mark that this is not a leaf and break out of the loop. But they all are null. We are about to leave the for loop. So now we move into the while statement. While the current node is not null pointer, or the parent of the current node is not null, well, here's the current node, the parent is this node, so it has a parent. Is leaf, well, is leaf is true because it has no children, and its occurrence is equal to 0. Well, its occurrence is equal to 0 because it was 1, but the very first thing we do is we decrement it. So we can go into the while loop, and we'll set parent as the current node's parent. So parent is this node right here. And now we will start the loop that looks in all the children of the parent. We'll go ahead and move the code up just a tad so we can see all of these numbers and this array. And we'll start at 0 and we'll increment by 1 each time. We will check to see if wherever we are, if that element is the current node, and we'll check to see if the element is null or not. So it's not the current node, it's not null, well then we can increment to the next one. And it's not the current node, it's not null, and just keep moving on. We can see that all of these are null and none of them are the current node. We just move right along until we get to over here. So now when we check, this node is the current node. So we can move inside this if statement and we can go ahead and make this null. Instead of making it point to the current node, we will delete the current node, and then we will make the current node equal to the parent. Then we will go out of there and we will continue searching through all the children because we need to make sure that the parent is a leaf. We need to make sure that the parent has no other children. So we'll continue our search through the parent. Everything is null. We're done with that for loop. So now that we're at the parent, we will repeat. We'll make the parent of the current node, and we will once again search through all the children of the parent. Move the code up just a tad so we can see what's going on. We will start from 0 and move all the way. We can see that it's null, see that it is not the current node. Move on to the next element. The next element is the current node. So the first thing we will do is we will make that element a null pointer. We will delete the current node. We will change the current node to be the parent. And then we will continue searching because we still have to search through every single element to make sure that this is now a leaf, that it has no children. So we can see that everything is null. Now we will break out of the for loop, go back up, and reevaluate the while statement. The current node, the parent, is not null pointer because the parent is the root. It is a leaf because everything is null. Its occurrence is 0. We will go back into the while statement. First thing we'll do is we will make the parent of the current node the parent of the current node, or we will point it to the parent of the current node. Then we will once again go through all the children of the parent. Move the code back down over here because I couldn't move it up any higher. And let's start going through, well actually, we don't even have to, the very first element is our current node. So that saves us some time. So since the very first element is the current node, the first thing we do is we make that element a null pointer. We will delete the current node. We will make the current node equal to the parent. And that's done with the if statement. We still have to finish the for loop. We still have to look at every single element, make sure that no other element has a node. So pretty much making sure that our current node at the moment is a leaf. It has no children. Once we reach the end of the for loop, we see that everything is null, that it is a leaf. So we will go back up to the while statement and we will reevaluate. If the current node's parent, so here's the current node, if its parent does not equal null, but its parent does equal null because we're at the root, which means this evaluates to false. So we will leave the while statement and we're done with the while, we're done with the if, we're done with the function. Go ahead and cross ABS off the list, and that is how you remove a node from the trie. I hope this was helpful. I hope it made sense. There is still one more video I'm going to do. We have talked about what a trie is. We've created the nodes. We've talked about inserting into the trie, searching through the trie, and deleting words from the trie. Now we have to talk about printing. Printing will be next. So I hope this is helpful. I hope everybody has a good day, and I will talk to you later. Goodbye.